Now, in our thermodynamic equations and laws, we have the first law which says that the second law which says that whenever you have energy conversions or energy reactions, there's always a loss of energy. So what that means is that in effect, you always have a change of energy. Now, in our world, in every aspect of our world, we have conversions of energy, and those energy conversions, they are imperfect, and that is why we have what is known as energy changes. Now these energy changes, it is like an adaptation, it's like an abstraction of our thermodynamic laws into chemistry. Now in energy changes, you can define energy changes in terms of the gain of energy or in terms of loss of energy. Now for example, when I eat, I've gained in energy, right? But when I do an exercise, or when I run, when I play table tennis, in effect, I'm losing energy. So that is called an energy change. And whenever you gain energy, now you can look at me as a system. As in a chemical system, in that chemical system, there's what is known as the absorption of energy, and that absorption of energy is known as an endothermic reaction. So whenever you have an endothermic reaction, it involves whenever there's an absorption of energy. So in a chemical reaction, whenever energy is absorbed, it's known as endothermic, and whenever energy is lost or given out, it is known as exothermic reaction. For example, in most neutralization reactions, for example, whenever we have a reaction of sodium hydroxide and HCl to form salt and water. In this kind of reaction, the standard heat of neutralization of chemical reactions is often minus 57.3. So what that means is an exothermic. Now the sign before the heat of reaction will give you the nature, whether it's endothermic or exothermic. So whenever the enthalpy of the reaction or the heat of reaction is positive, is an endothermic reaction. Whenever the heat of reaction is negative, is an exothermic reaction. Now in general, neutralization reactions are always exothermic because the system has to give us energy. So it gives us energy in order to form salt and water. Then we have endothermic reactions. We have the reaction part and the reaction diagrams. So in simple states, whenever you are asked to diagrammatically understand and illustrate these changes, you can talk in terms of the energy, E and E are GY, and the time. So for endothermic reactions, your energy always starts from a low level, and then when it gets to a particular stage, it picks up and then gets to the final stage. And this is the reactant, this is the energy of the reactant. Then when the reaction starts off, there's an amount of energy needed to spur this reaction. So this is the activation energy from this peak to this low of the reaction. This is the activation energy. Then when at the end of the day, when it goes down to the final destination, this is the product end, and then from the difference between this peak and here, this is the difference between this final and the initial is known as the heat of reaction, or the enthalpy change of the reaction, and it's known as delta H. Now this energy change, if it is positive, it is an endothermic reaction. For this kind of reaction, whenever your initial state is lower than your final state, is an endothermic reaction. But for exothermic reaction, whenever you have your loss of energy, you always start from a high point. Your reaction is high, then it gets its activation energy, then it peaks down. So and then this is called an exothermic reaction. This is your activation energy. Distance between the peak and the reaction end, that's activation energy. Then the difference in height between the final and initial state is known as the heat change of the reaction, that's delta H. So and this is basically endothermic, and this is exothermic. So in summary, what this means is that in endothermic reactions you gain energy, in exothermic reactions you lose energy. Thank you for watching.